Let's talk about shapes. So if you are a spatially oriented person, I think you're going to like this unit because we're going to be looking at polygons. Polygon just means a shape that's closed with straight sides. So for example, all these figures down here, those are polygons. Some terminology. We're going to use the word congruent. Congruent just means that two shapes are congruent if they are the same shape and the same size. So all the measurements need to match up. The angles should be the same between the two shapes. The side lengths should be the same between the two shapes. Everything is the same from one to the other. There's another category that we're going to use, and that is similarity. This would be two shapes that are the same, shape, but different sizes. For example, imagine a small circle and then a larger circle. Those are similar because they're both circles, but because they're different sizes, they're not congruent. So similar is same shape, but different size. And when we're talking about polygons, so again, our straight-sided figures, then similar polygons are going to have angle measures that are the same thing and side lengths that are proportional. The very first thing we're going to do here is check whether or not figures are similar by looking to see, are the angles the same between the two figures and are the side lengths proportional? So here we go. For this set on the left, let's take a look. I want to make sure you understand what the different markings mean. Any angle that has one mark is the exact same size as any other angle that has the one mark. So bottom angles here and bottom angles here, they all have the same measurement. However many degrees one of them is, all of the others are that same size. Any angle that has two marks is the same size as any other angle that has two marks. So the top two angles in the figure above and the top two angles in the figure below are all the same size. So our first check to see if the shapes are similar, the corresponding angles should be the same. That matches up. Because once your shapes are oriented the same way, meaning kind of pointing the same direction, you just look to see, is the top left angle the same as the top left angle? Is the top right angle the same as the top right angle? That's what we mean by corresponding. Is the bottom right the same as the bottom right? Those correspond with each other. Bottom left same as bottom left. And yes, based on the markings, those all match up. Now let's check proportionality of the sides. For this, when we say sides are proportional, what I mean is, if I take corresponding sides, like the top here compared to the top here, and if I make a fraction out of them, so 16 divided by 20, I'm just going to use my handheld calculator here. 16 divided by 20 is 0.8. If the side lengths are proportional, then when I do a similar fraction with other sets of corresponding sides, I should get this exact same 0.8 number. So let's now check the sides here on the right. So on the right and on the right. 15.2 divided by 19. All I'm interested in is, am I going to get the same result? Is it still going to be 0.8? Sure enough. Okay, so far so good. Now, this is a little bit handy in that because this other left side is the same numbers, we don't need to recheck it. We're going to get the 0.8 again. And now let's check the bottom. So a 28 and a 35. So 28 divided by 35. Do we get 0.8? Yes, we do. Very nice. Okay, because I got that same ratio all three times, yes, these side lengths are proportional. So corresponding angles are the same. Corresponding sides are proportional. We got the same result each time. Yes, these shapes are similar. Let's now move over here. We see here two parallelograms. Now, when you see, there's different markings here, right? You got these little arrows. Anytime you see the one arrow, any segment that has the one arrow on it means those are parallel to each other. So 1, 2, 3, 4, those are all parallel to each other, those four sides. Anything that has the two arrows on it, those are also parallel to each other. So the arrows indicate that, yeah, top and bottom are parallel in both figures. Let's run through our checks. Check 1. Are the corresponding angles congruent? So this angle here is 40 degrees. The corresponding angle in the other figure. So this was my bottom left angle. Here my bottom left angle is 45 degrees. 40 and 45 are not the same number. If any of the angles aren't the same, you don't need to check any further. No, these are not similar figures because the angles aren't the same between them. Now be very careful, because if you do a proportionality check on the sides, that's going to check out. You're going to get the same number when you compare top to top and left to left. But make sure you're also looking to see whether or not those angles are the same between the two figures. All right, so that's how you check to see if figures are similar. Now let's talk about how, if you know figures are similar, you can figure out some information that's missing. So we're being told, hey, this shape up here, which looks maybe like a trapezoid, and this shape down here are similar. So same shape, but different sizes. We're asked to find out how long this bottom side is at the bottom. We're going to take advantage of this proportional relationship between the sides to set up a ratio that we can then solve. Let's see how it works. The first thing I need to do is say, okay, this is the one I want to know. I need to find the corresponding side in the other figure and make a fraction out of them. And it doesn't matter what's on top and what's on bottom as long as you are consistent. So if I put the question mark on the top, and if I put the 32 on the bottom, that means that I'm taking the measurement from the bottom shape for my numerator and from the top shape for the denominator. The next thing you need to do is to now find another set of corresponding sides that you have measurements for. So for example, if I look here, I've got the right side measurement on this bottom shape, but I don't have the right side measurement on the top shape, so that's not helpful because I'm looking to be able to set up another fraction over here. Up here I have the top measurement, but on the lower figure I don't have the top measurement. But on the left side, now we're in good shape. I've got a 20 down here and a 16 up here. So if the question mark was on the top of the first fraction, the 20 is on the top of the second fraction. And this is now something that you can cross multiply and solve. So let's take 16 times question mark. And if you want to call that x, you can call that x, whatever makes you happiest. And then on the other side of the equal sign, multiply on this diagonal, 32 times 20, it's going to be 640. So to solve for the question mark then, divide by the 16. So 640 divided by 16 gives us that missing length, the one that we don't know, has to be 40. Now do a quick check, see if that seems reasonable. I notice that as I'm going from the top figure to the lower figure, the numbers get bigger. So from 32 to question mark, I should get to a bigger number. 40 seems like a reasonable answer. Okay, let's go again. This one, I would like you to do a pause here, try it yourself, and then unpause when you are ready to check. Okay, so I got question mark and 12, and then I've got 5 and 20. Now do a quick check. If question mark is on top of my first fraction, then 5 needs to be on top of my second fraction. If they come from the same shape, they need to be in the same spot. Do now a cross multiply. So 20 times question mark equals 5 times 12. We're then going to divide by that 20. And so question mark looks to be 3. do a reasonableness check to go from the left rectangle to the right one. The numbers are getting much smaller. You're dividing by 4, actually, because 20 divided by 4 is what gives you 5. And 12 divided by 4 gives you 3. That dividing by 4 is sometimes referred to as the scale factor. Okay, last one here. Once again, I would like you to do a quick pause and then unpause when you are ready to check. Okay, corresponding sides, so setting up one fraction. And now you've got choices here. Because you've got the 40 and the 32 that are corresponding, you could set up another fraction with those. You've got the 25 and the 20 that are corresponding. You could set up a fraction with those. Either one works. Make sure, though, that you have, if question mark is on the top, the 25 needs to be on the top. Okay, so that's all in the right spot. Cross multiply now. 20 times question mark equals 25 times 16. That should be 400. Sure enough. Divide by the 20 to finish off. And we end up with, question mark equals 20. So once again, a reasonableness check. From left shape to right shape, the numbers go down a little. So this should be a number that's a little bit bigger than 16. I think 20 looks reasonable. So we are in good shape.